Everyone, this is Mr. Rowe. We're looking in Algebra 2. We've got a situation where we need to model a quadratic equation to the situation and then kind of figure out some information about it after we do that. So here we have a farmer. He has 300 meters of fencing to enclose a rectangular pen. Anytime you're given something that's visual, I like to draw the picture of the visual. So we got a rectangular pen and it says it has 300 meters of fencing. Well, what does that mean? That's the perimeter. So the perimeter around the outside is 300 meters. So that's where we're at. We want to write a quadratic to model the situation. So since we have a perimeter piece of information, we're going to have to use that to figure out the length and the width, and then use that to kind of model the equation. So in the problem, it tells you, the one that you're going to do, it tells you that you're given the width. So we're going to do the same thing. So we're going to assume we know the width. We need to find the length in order to write the quadratic. So here's the situation. Perimeter equals 2w plus 2l. We're going to substitute what we know, which is that the perimeter is 300. So we know that. And then our job is to solve for L. So we're going to subtract 2w from each side. That gives us 300 minus 2w equals 2l. And then if we divide by 2, we'll get 150 minus w equals L. And so there's our length and there's our width. We have our width. We know our length. Our length is now 150 minus w. And so we can model the situation with area equals the width times 150 minus w. And so that'll simplify into 150w minus w squared. All right, so that's the model for the situation. That's the area function. Now, what is the greatest area? Okay, so let's talk about quadratics. Quadratics, form these parabolas where it goes up and then it comes back down in a symmetric pattern with the vertex being the max in this situation. Now, why is it curved like that? Because that's negative right there. That's going to curve it. So what I know is that the vertex is going to represent the max height. So I'm going to rearrange this a little bit. Negative w squared plus 150w. And how do you find the vertex? The vertex, you use this formula, opposite of b over 2a. So we're going to apply that rule. And so in this case, the opposite of b, negative 150 over negative 1 times 2. So this will be negative 150 over negative 2, which is 75. So that means that max height right there. So the max area is going to be where x, or in this case w, is 75. And so what are we going to do now? We're going to substitute that into our formula. So let's change colors so we don't have everything the same. So I've got my area equals w, or let's rewrite that. 150w minus w squared. And so we'll have 150 times 75 minus Mr. Rowe, 75 squared. And what I want you to do at this point is I want you to pull up Desmos or scientific calculator. So I got the graphing one up. To add the scientific one up? It's right there. I'm going to clear that. And then we're going to substitute that in. And you can type it in just like it's written. So I'm going to do 150, open a parenthesis, 75. This is the great thing about Desmos, is it understands what you're doing. And there it is. So the max area is going to be 5,625 meters squared. So 5,625 meters squared. So the max area, 5,625 meters squared. Now the second question, what's the length and the width of that enclosure with the greatest area? Well, we already know that the width is 75. So we know that the length is 150 minus W. So that's going to be 75. And that makes sense that a square has the biggest area. So the length is 75 and the width is 75. And let's just to kind of get this so that you kind of can understand it. I've got Desmos graphing calculator here as well. I like to kind of use it to help model situations. So here we're going to change this into y equals, and I'm modeling this function right here, 150w minus w squared. So 150x minus x squared. So there's that parabola. And now here's another cool thing about Desmos. You can create a table. And so I'm going to let x be x, and then I'm going to let my y equal that. You see, I'm just copying and pasting. And watch what happens here. I put in 0, I get 0. Let's just go by 25 since 75 is the area. So you got 25, you get 3,125. Go 50, go 75, and there's the area that we got, the max area. And you see it's at the tip of the parabola. Let's go 100, and you see it starts going back down. And if we go to 150, we get back to the 0. So there's the parabola, and that matches up with what we got, so that makes sense. So I hope this helps you with a similar problem that you're having in your lesson. If not, let me know, and we'll find some additional resources or maybe find some time to meet so I can help you out.